Welcome to Beta Online Learning. This video for the 12th standard CBSE Mathematics will present all you need to know about differential calculus. This is a topic for the 12th standard CBSE Mathematics. In this video, this is a part 1 of the video. In this video, we will cover the basic concepts of differentiation, rules of differentiation, and methods of differentiation. The basic concepts, of course. The basic concepts are, what is differential calculus, first of all? Differential calculus is a branch of mathematics that studies how quantities change at a rate. It involves finding the derivative of a function, which is nothing but the rate of change of a function at a specific value. Differential calculus is one of the two main areas of calculus. The other area of calculus is integration or integral calculus. In differential calculus, we call limit delta y, del y by del x is called the differential coefficient, or simply the derivative. The differential coefficient of y with respect to x. Here we have defined two variables, x and y. Y is equal to f of x, as we will see that. Y is the dependent variable and x is the independent variable. It is represented by dy by dx. This is read as limit of delta y by delta x as del x tends to 0. We know that quantities whose values change continuously are called variables. The rate of change of a variable with respect to another variable is called the differential coefficient, or simply derivative of a function. Let us define differential coefficient in terms of two changing quantities or two variables x and y. Let y be a function of x. We can write y equal to f of x. So y is the function of x, and based on the domain, the value of x, the range, that is the value of y, varies according to that. Let del x be a small increment in the value of x, and the corresponding change in the value of y is del y. Now, if we denote the small increment in x, del x, as h, then we can write f dash of x is equal to limit h tends to 0, f of x plus h minus f of x by h. This is the definition of a derivative from first principles. Wherever the limit exists is defined to be the derivative of f, which is denoted by f dash of x. The derivative of f is denoted by f dash of x, or d by dx of f of x. Or if y is equal to f of x, we will denote it by dy by dx or y dash. The process of finding the derivative of a function is called differentiation. We also use the phrase differentiate f of x with respect to x to mean find f dash of x. In fact, differential calculus finds applications in physics, especially the fields of kinematics, rotational dynamics, and electrical technology. The field of mathematics, it finds applications in finding rate of change, tangents and normals, close approximations, increasing and decreasing functions, maxima and minima, and so on. These are some of the applications of derivatives, differential calculus. Now we will go on to the rules of differentiation. Let u and v be two functions of x, and the dashes or the superscripts denote the derivative of the functions u and v with respect to x. Then we can say, we can define rules like addition or subtraction rule. U plus or minus v the whole dash is equal to u dash plus or minus v dash, which is the sum of the two derivatives of u and v with respect to x. Product rule is also known as Leibniz rule. If y is equal to u into v, that is product of u and v, the two functions of x, where u and v are the functions of x, then we have dy by dx is equal to u into dv by dx plus v into du by dx, or uv the whole dash is equal to uv dash plus vu dash. This is the very important rule known as product rule, where the multiplication of two functions with respect to x, that is functions of x, are being differentiated. Next, we have the division or quotient rule, which involves the quotient or the division of two functions of x. D by dx of u by v is equal to, now we know that this is the important rule, v squared comes in the denominator. The denominator of the function becomes v squared here. We differentiate this way and we put v into du by dx minus u into dv by dx, or u by v the whole dash is equal to vu dash or u dash v is minus u v dash whole divided by v squared, wherever v is not equal to 0. Chain rule is another very important rule. It's also known as function of a function rule. Let f be a real valued function, which is a composite of two functions, u and v. Then v is a function of u and u is a function of x. So it's a function of another function, vo. It is also known as VOU. We'll also write f is a v of u. V is a function of u and u is a function of x. Suppose t is equal to u of x. Let us assume that t is a function of u of x, that is function of x. Say u of x. Then if both dt by dx and dv by dt exist, we have df by dx, where f is a function of the u and v, let us say t and v. So dv by dt, first we have to differentiate with respect to t and then t with respect to x. It's a multiplication. This is a chain rule which extended to composite functions of more than two functions. Example of chain rule here, we have given an example of how we differentiate dy by dx if y is equal to sine of x squared. And sine is actually, here u is the function of x, which is x squared. V is a function of u, which is sine u. Let us say it is u here. The composite function VOU. We now define dy by dx is equal to du dv by du into du by dx. We will see that later, what are this, how the differentiation is being taking place. We will write it as sine u. When you differentiate, you will become cos u. And then into 2x. We are differentiating that x squared term. Du by dx is nothing but 2x. We will see that standard forms of derivatives. Therefore, it becomes 2x into cos x squared. This is one form. These are some important standard forms. Definitely, we should know all these standard forms of derivatives before we start doing differential coefficients. Before solving problems on differentiation. Now, in this table, we have very important standard forms, basic standard forms. We have given it in a certain order so that you can easily remember. See, y equal to f of x, let the function be x power n, x raised to any power, except the negative one. That is why that's the only thing here. There is a separate thing for that, because if x power 1 minus 1 is there, then it will become 1 by x. So that alone is not. So here n into, the thing is n into x power n minus 1. So here we have negative x. So x power minus 1 is 1 by x. We can also write this. That condition is that x is not equal to 0, of course. But other conditions, it is valid. So n into x power n minus 1. So n into x power n minus 1, any power raised to any power, we can differentiate this, even if it is n is a rational number. So here we have a power x. A is a constant. Power raised to a power variable x. We can write this as a power x log a. Log of mod x, because log cannot be, log of a negative value is not defined. So we will take it as x greater than 0. Log of, and log 0 is also not defined. So x greater than 0. So here we take only the positive values, greater than 0. Log mod x is given by 1 by modulus x. 1 by x is derivative. The derivative of 1 by x is minus 1 by x squared. This is found from this standard form itself. We can put x power minus 1 and see. You will get the same answer. Root x is x power half, as you know. X power half, it can be differentiated using this standard form, n into x power n minus 1, and you will be getting as 1 by 2 root x. Further standard forms are trigonometric functions. Trigonometric functions, given all the 6 trigonometric functions here, sin x becomes cos x when differentiated. Cos x becomes minus sin x when differentiated. Tan x is equal to tan x. If you differentiate, it becomes secant squared x. Cot x is minus cosecant squared x. Secant x is differentiated as secant x tan x, and cosecant x is differentiated as minus cosecant x cot x. Now let us see the inverse trigonometric function, sine inverse of x, 1 by root of 1 minus x squared. Along with it, you can just have some other, we will also differentiate the cos inverse of x. It is nothing but minus 1 by root of 1 minus x squared. Tan inverse of x, when differentiated, gives you 1 by 1 plus x squared. There are other standard forms also. As and when we solve problems, we can come across those things. But these important standard forms are used for solving problems in differentiation. Methods of differentiation. In this video, we are going to see the 1 to 5. In part 2 of the video, we will see differentiation of parametric functions, Rolle's theorem and Lagrange's mean value theorem, second order derivatives. These 3 will be covered in the next part 2 of this video. That is, part 2 is the next video. In this video, we will only restrict our discussion to the first 5 methods. Methods: differentiation of algebraic functions, differentiation of trigonometric functions, differentiation of implicit. In trigonometric functions, we will also include inverse trigonometric functions. Differentiation of implicit functions, where y and x are not being easily separated. So just like that, in a mixed form, it will be there in a function. It's an algebraic expression involving x and y. Differentiation of logarithmic and exponential functions, log x and e power x. That also has to be covered. Logarithmic, we know that log x is 1 by x. Exponential is e power x, which is also e power x itself. Logarithmic differentiation is a method by which you can take logarithm on both sides and then differentiate. This procedure will follow. We will use the basic rules of differentiation like product rule and quotient rule, and division rule or quotient rule in these methods. First of all, we will see one important worked example for the differentiation of algebraic and trigonometric functions using chain rule or the function of a function rule. You see this function sine of x squared plus 5 is a trigonometric function which involves an algebraic function as its argument. So this is a function of a function. So here we can also do this by putting x squared plus 5 as t and then differentiate. First, we have to differentiate sine with respect to t, and then the t with respect to x, and multiply. That's all. So we will do this directly now. D by dx of sine of x squared plus 5 is equal to, first, the sine will be differentiated. The function sine will give you cos. On differentiation, cos of x squared plus 5. And then x squared plus 5 is differentiated with respect to x. We will get 2x. Of course, differentiation of a constant is 0. So constant is derivative of a constant is 0 because it doesn't change. Only changing quantities that differentiation is derived. Variables. Constant doesn't change, so the rate of change is 0. So here you have 0 here. So cos of x squared plus 5 is as it is, you get the sign becomes cos here on differentiation. And when we multiply this by 2x, we'll get 2x cos of x squared plus 5, which is the required answer. Hence, we use the standard forms of algebraic and trigonometric functions and the chain rule. Next, we move on to implicit differentiation. We have an example over here. You see, find dy by dx if 2x plus 3y is equal to sine x, which is an implicit function because x and y are involved in this expression. Here, even though we can express y in terms of x, it seems to be complicated. So we will do this implicitly, that is by differentiating each term on both sides separately. Differentiating the given relation with respect to x, now we get d by dx of 2x plus d by dx of 3y is equal to d by dx of sine x. Here is sine x, not sine y. It should be sine x. So sine x, when you differentiate, it becomes, it should be x over there. So it will be x. So since it's sine x here, if it is sine y, it will be sine y. It's actually sine, the question is actually sine y actually. So here it should be sine y. So sine y means we have to differentiate it with respect to the chain rule. Cos y, and then again with respect to x, dy by dx. It is actually an implicit function involving y. So cos y into dy by dx. 2 is as it is here. We are bringing all the dy by dx terms to the one side. With change of sign, we have just brought it to the other side, minus 3 here, cos y minus 3 into dy by dx, combining these two terms. And dy by dx is equal to, we divide both sides and then 2 by cos y minus 3, which is the required answer. Note that the dy by dx, the differentiation, involves the function y. Logarithmic differentiation is dealt with separately. There is a separate video on this. The link is given in the description box. You can check it out. Link for this video, because we have covered this. We use this classical problem of x power sin x plus sin x power cos x. Solution to this question and other questions also are given in the upcoming videos, and there's another video on this. The link for this video is videos. Actually, there's one more problem which will be solved using the logarithmic differentiation. Here we have to take logarithm on both sides and do that. And in the upcoming videos, the link is links are given in the description box, and there you can find the solution to these problems. So here we have covered most of the basics. In this video, part 1 of this video, we have covered the major basic differential calculus, the rules of differentiation, the basic concepts of differentiation, and then we come to the rules of differentiation. We have come to the rules of differentiation, the product rule, the algebraic expressions, and so on, and the quotient rule. Chain rule is a very important rule, is the chain rule, function of a function rule. Next, we covered some of the standard forms of derivatives, both the algebraic and trigonometric functions and logarithmic functions. And we also covered a few of the methods of differentiation. The differentiation of parametric functions, Rolle's theorem and Lagrange's mean value theorem, and the second order derivatives will be covered in the part 2 of this video. We have also worked out a few examples for the algebraic, trigonometric, and implicit as well as logarithmic differentiation. Thanks for watching. Have a great day.